this video, we'll be talking about scaling and load balancing, which are two very important concepts of system design. And given this video is all theory, so we'll be making use of some analogies so that we can understand things pretty clearly. So to start with, let's assume you are running a restaurant. So you are working single-handedly at the restaurant. You are like serving, say, 500 customers over the entire day, and things are working pretty much well. But after a point in time, you people notice your shop and they notice that you are serving good quality of food or stuff, and the number of customers that those are visiting your restaurant has increased over time. And now it's like it is you are not able to serve them well. Some of them are returning dissatisfied. So what will you decide? You might decide to like have some helpers. You might decide because they don't have space to sit and eat, so maybe you'll increase the space there. So basically, you add in more capacity to your restaurant. It can be in a form of space. It can be in a form of humans who can like basically reduce your workload, that kind of thing. Now, after a point in time, you understand that people are really liking whatever food you are serving, the taste of your food and stuff, and the number of customers have increased significantly. It is not possible to serve them at a single place, even if you add in more space to your restaurant or add in more people who is working at your restaurant. So, what do you decide? You decide to open multiple branches at different possible locations, right? So these are the type of scalings we'll be talking about when it comes to our servers. One way is to increase the capacity of your existing restaurant or existing server, and other way is to deploy multiple restaurants or multiple servers. So this might sound confusing for a bit. So let's we have understood how things work in real world. So let's get back to how it works in terms of the servers and the application requests, all of this. So to start with, let's assume we have a server. So whatever numbers I'll be picking, those are just dummy numbers to help you understand the overall idea and doesn't have anything to do with how things actually work. These are like dummy numbers I pick so that you can understand the concept rather than focusing on, okay, these numbers map to this or that. Cool. So suppose this is server one, and this has got 4 GBs of RAM and say 2 core CPUs. Cool. Now, assume our average traffic or the request coming to the server. So let's say this server is capable of serving 50 requests per second. Okay, and our daily average, like not daily average, the number of requests we receive, the average request is below 50 requests per second. So things are running pretty smoothly. Our server is able to serve the traffic well. But after a point in time, people notice our website, people notice our software or our application, and the amount of person visiting our traffic, like the amount of traffic which is visiting our server has increased. So the amount of traffic visiting our server increased to say 100 requests per second. Cool. But we know that because this particular server is incapable of serving this huge request, many of these requests are dropped and all they receive is a 500 error. And our server keeps crashing because of the huge amount of like overwhelming number of requests. It's not able to process them, it's not able to respond to them. So that it keeps crashing. So the first thing we can do is to increase the capacity of our server. What we really do is we upgrade our server. So our new server, this is the same like single server, but it has increased capacity. This has got like 8 GBs of RAM and say 4 core CPUs. So now this is able to serve 100 requests per second. Pretty fine, pretty smooth, and we are no longer facing the 500 errors. Our service is no longer crashing. But as you know, similar to what happened with our restaurant, people notice that we are giving them a good product. So the number of people visiting our website has increased. Say it has increased from 100 requests per second to 500 requests per second. And we know that even like we can upgrade our existing server's capacity to a certain limit. Beyond that, there is no point. Uh, Even if you increase the server's capacity, it is no longer going to be helpful. So what we need to do in those cases is instead of upgrading, we reduce the workload of a single server and rather deploy multiple servers. So instead of having this single server, what we do is we have 5 different servers running: server 1, server 2, server 3, server 4, server 5. And all of these, like each individual one has like 8 GB of RAM, 4 CPU. So each of them is capable of serving 100 requests per second pretty smoothly. And our average has increased to 500 requests per second. So if we distribute like the request over these many servers, we can easily serve our traffic and none of them will get a 500 response, none of them will be left dissatisfied, so we won't lose our customers. So this whatever so to talk about we what we did, upgrading our server's capacity is one form of scaling, and this form of scaling, this upgrade part, is known as vertical scaling. Cool. And this, where we increase the number of servers we have. This form of scaling is known as horizontal scaling. So these are the two forms of scaling, and these are pretty helpful to address the increasing number of traffic. Now we have understood what are the different types of scaling, but the next question being, if we have n number of servers deployed, how will our client or the one making the request know which server we should send request to? Because say uh, let's take example of Google. Google will have like lakhs of servers deployed, right? But are we the one deciding, okay, I would connect to server one, server two, or the nth server? No, right? So what we have in place is a load balancer. And behind this load balancer are the different servers connected. Say server one, server two, server three, server four, and server five. So what whatever the client's request is sent, that is received by the load balancer, and load balancer is the one who decides, okay, I need to distribute this incoming traffic. Say this is client one, this is client two, this is client three. It's the load balancer which decides, okay, where I will be forwarding this traffic. As a client, we request, say, we send request to google.com, which points to the load balancer. And this load balancer is the one responsible for deciding where the request will be forwarded. So suppose there are different algorithms based on which the load balancer distributes traffic. But very simple one is, suppose the first request which comes, uh, let me pick a particular color, say this one. Okay. So this is the request one. Request one came, it redirects to the first server. Now first server is serving the request, so it is busy. Say all it has a certain capacity that it can serve 100 requests per second. So say the first 100 requests will be sent to server one. Once the server one is busy because load balancer keeps check of the health of the server, the usage in terms of the RAM usage, the CPU usage. So in case it finds that server 1 is busy, it will redirect the next request, maybe coming from client 2 to say server 2. So it follows an algorithm which we will be talking about in our next video, and it basically follows an algorithm to send the traffic or send the request to different servers, and then the server processes the request and returns the response, which goes to the load balancer, and load balancer forwards the response back to the client. So that is how scaling and load balancing works together. Hope you found this video helpful.